Did I win Calvin's 10,000 pound global earth challenge with my last video? Stick around to find out. Today's video is sponsored by Penny Chewer's Playground. This cool game was developed by Michael Burnage, who is an indie game developer from the UK. There's 12 islands to conquer where you win cash for weapons upgrades by eliminating enemy troops. It's got game modes including zombies, hunted, sniper, and deathmatch. There's a ton of different weapons, outfits, and armor. I love that the interface has a rather rude and sarcastic attitude. Best of all, there's no pop-up ads, it's free, and it's not play to win. Thanks, Michael, for reaching out to sponsor this video. Show him some love, guys, by downloading Penny Chewer's Playground for free today on iOS or Android. Links in the description. Welcome, everyone. I'm Nick Oz, and I'm an engineering tech. I love construction, design, CAD, and I love to follow flat earth debunking. If this is your first visit to my channel and you like this kind of content, please consider subscribing and hitting that thumbs up button. I'd really appreciate it. I'm also really hoping that Calvin gives me a response, so please consider hitting that bell icon to get notifications on new content. Thanks, guys. I got some really interesting comments on the last video, along with over 1.7 million views. I can only guess that the YouTube algorithm suffered a massive technical problem, and people searching for Wiz Khalifa were accidentally redirected to my channel because of the reference to the Burj Khalifa in my previous video. Anyway, a lot of the comments were asking for clarification and additional detail, so here we are. Now that all that stuff is out of the way, it's time to get into the new video. Let's go. Of course I didn't win. At least I haven't heard a peep from Calvin anyway. He might have fallen off the edge of his flat earth, plus the comments on his video have been disabled. By the way, judging from some of the comments from flat earthers on my previous video, everything I'm about to show you is completely invalid because I'm using computer software that's been designed by globe earth biased programmers from Autodesk in collaboration with evil NASA to deceive humanity. In other words, it's CGI. I love you, Creaky Blinder. Keep up the good work, mate. So let's take a look at why scale matters and why some flat earthers can't seem to wrap their heads around this. I'd say Calvin's whiteboard globe has a radius of about 1 meter, and his smallest building is about, let's say, 10 centimeters. Scaled up to reality, in relation to the Earth, Calvin's smallest building would be a whopping 637.1 kilometers high. I've made adjustments to this building to show how the outside walls would be angled away from one another if a laser level or plumb line were used to line them up using gravity. The dimensions are also rounded off for simplicity. We can see that the floor of Calvin's building is 637.1 kilometers wide. And interesting to note that the roof is larger at 700.8 kilometers. And the reason for this is because we used plumb lines taken from the center mass of the Earth all the way up to the outside walls to give us our angles, like we did in the previous video. I think one of Calvin's arguments is that we don't see buildings with curved roofs, floors, etc. that compensate for the Earth's curvature. I can see where he's going with this. For example, if Calvin's building were real and had a perfectly flat floor, it would be interesting to see how far the floor would be elevated from the Earth at its farthest distance. So we can see here that the distance between the Earth's base or curvature and the base of Calvin's flat floor of his building is 7.9 kilometers. Of course, this is completely unrealistic, but let's verify this number with an Earth curvature calculator. In order to do this, we need to know the distance from the point at which the building touches the Earth all the way to the farthest edge. So half of 637.1 kilometers is 318.55 kilometers. I'm using a simple calculator called Earth Curvature Calculator, available at omnicalculator.com. And let's just punch in those numbers. We said 318.55 kilometers. We can see that we get a distance of 7.9 kilometers. So the math works here, guys. In the real world, engineers have to compensate for Earth's curvature all the time when designing and building massive structures, like long span bridges and underground train systems. If these calculations aren't taken into consideration, we can end up with major problems. So this is why scale matters when you want to make an accurate representation of reality. Let's dive a little deeper and do some real-world experiments in AutoCAD to further prove that you can build buildings on a global Earth with laser levels and plumb bobs. In this example, I'll use a building that's a bit more realistic. Let's use the Freedom Tower in New York City. The tower is 541 meters high to the spire by 61 meters wide at its base. It has 94 floors. Here's Calvin. I'm guessing he's about 5'10", so this should be accurate enough for scale. I need to point out something pretty obvious here, and that's that using plumb bobs and laser levels would not be a practical way of achieving 90-degree parallel exterior walls on a building of this scale. In the real world, this would be achieved by laying dimensions from a reference point on each floor to the outside of the building. But what I'm going to show you is that it could be built this way, and we'd never know the difference. Instead of a plumb bob, this time around we'll use a laser level. A laser level works on the same principle as a plumb bob, except in reverse. A beam of light shines out the top of the laser level, and the angle of the beam is determined by a weight at the bottom of the laser level, which points to the center mass of the Earth. It doesn't matter where you are on the planet, and this works in 3 dimensions. The weight at the bottom of the laser level will always point to the average center mass of the planet. In turn, the laser beam will point in the opposite direction. Now let's place our laser level at the base of our tower. I'm going to select it and rotate it using the center of the Earth as a reference. And as I zoom out, you can see that the level beams extend to infinity beyond the edge of the globe. Now I'm going to mirror the laser level to create a duplicate on opposite sides of our tower. So now we have 2 of these placed at opposing ends of the base of our tower, and both are level using the Earth's center mass as a reference. Now that we have our laser levels placed, we can create our angular dimension to see exactly how much the 2 lines deviate. Tiny, infinitesimal, but real. To show you just how ridiculously small this angle is, I've drawn a green line exactly 1 million kilometers away from the base of our tower. Remember, the base of our tower is 61 meters wide, and at this distance, our laser level lines deviate by about 9.6 kilometers. Please tell me I'm not the only one that finds this kind of stuff cool. Next, we can take a look at the difference in length between the floor and the roof. The floor at grade, as we know, is 61 meters wide, and our new roof is now 61 meters wide, plus a tiny little bit. When we do the conversion, this works out to a difference of 4 millimeters, roughly. Funny thing is, I'm betting that the actual deviation on a building of this scale is more like inches, because we can never build to these sorts of tolerances in the real world. But again, this just proves to Calvin why we'd never see a building with a roof wider than its base if it were built with a laser level or plumb bob. I need to clarify that I am not trying to prove a global Earth here. That has been done countless times by people who are much more established on YouTube than me. It's also been proven countless times by anyone who's seen the moon in its various monthly lunar phases. What I was attempting to demonstrate in my previous video is that you can use plumb bobs, laser levels, levels of any kind for that matter, for the purposes of construction on a global Earth. You can indeed construct buildings on a globe with curvature. Well, that pretty much sums it up, folks. I hope it clarified a few things. I encourage you to check out my previous video and look at the comments section. There are some comments from flat earthers there that are worth way more than 10K in entertainment value alone. If you'd like me to do another video going through some of these, let me know in the comments section below. And Calvin, if you're watching and this video in any way convinced you that we can use traditional tools such as laser levels and plumb bobs for construction on a global Earth, I really encourage you to donate that £10,000 to a charity of your choice. Seriously. You seem like a nice guy, and I certainly hope you don't take anything I've said here in this video personally. The jabs were only intended to keep things light for the video. Thanks everyone. I plan on making more content on this subject really soon, so please make sure to subscribe. Cheers.